Hello everyone, thank you for joining me today. Please allow me to introduce myself. I am Sanaula from Bielefeld University of Applied Science and Arts located in Germany. Today I would like to present our study based on graph neural network and their application to graph structure data. Later on we will also demonstrate our real-time simulator tool which allow you to visualize the training procedure of graph neural network at runtime. So let's start. We will follow these chapters starting from the introduction, the motivation and objective behind this study, and the dataset which we use in our study, and the proposed automatic selections algorithms, and the real-time visualization tool, and the demonstration, and in the end we will discuss about the future direction of this study. So graph neural networks have gained significant attention in recent years because they can effectively model and analyze data with complex relationships such as social networks, molecular chemistry, and so on. So graph neural networks are specialized class of the neural network that operate on graph structure data. For example, unlike traditional neural networks that are designed for Git-like data structures such as images or the text sequences, but the graph neural network inherent connectivity and the relationship within the graph process information that makes its uniqueness and different than the traditional neural networks. In graph neural network, generally the data elements are represented as nodes, and the relationship between them are represented as edges. So, one of the key aspects of achieving optimal performance in a training graph neural network or any other neural network is the selection of appropriate loss and optimization function. As we know that the loss functions are playing a quite important or vital role in a training procedure because the loss function measure the differences between the model predicted output and the true target values. On the other hand, the optimization function determines how the model parameters are adjusted based on the loss value, aiming to minimize the loss over time. It guides the learning process by quantifying the model performance and allowing it to update its parameter accordingly. So the objective and the motivation behind this study was to tackle this challenge by automatically selecting the best loss and optimization function for our graph neural network training. Traditionally, domain experts manually choose these functions. Researchers, they manually choose these functions based on their prior knowledge and annotation. But these are the time-consuming process, right? For example, you used one set of the function, like say the loss function, optimization function, and the learning rate, and then you get the result maybe let's say in 10 hours or so on. If the data set is bigger, you have to wait maybe even a week. So and then you receive the result, but that didn't make you satisfied, and then you thought that okay, explore in a different loss function, the set of functions, and then you use the different algorithms, and then you implement it again, and then you wait 1 week more. So it's a time-consuming process, and it may not yield the best result due to the complexity and the uniqueness of each data set. So that's the one motivation behind this study that motivate us to think in a way that the manual selection of these functions will be reduced or minimized as much as possible. So for this purpose, we study the graph neural network training procedure using automatic selection of the best loss and optimizer function using the best matrices, best performance matrices. Later on, we will see about how the algorithm is working using the best performance matrices. And there is one more motivation behind this study as our main research field was spiking neural network, the third generation of neural network. And in spiking network, we have a bunch of hyperparametrics values, and it's a differential based on differential equations. And to make the balancing between these hyperparametrics value, it's quite challenging stuff for the SNN community. So we are exploring at the moment to select those hyperparametrics value automatically, and for that purpose we need to understand the architecture flow And as SNN spike neural network sites, we don't have much information about in this kind of architecture. So we thought that initially we will explore this area on the second generation of neural network, which is a part of the also graphic neural network. So, to further improve the training process, we implemented a learning rate scheduler that adjusted the learning rate based on the model performance. To be noted, the learning rate scheduler is used in our algorithm is the combination with the best loss and optimization function. It updates the learning rate based on the best matrices achieved by the best loss function, ensuring that the learning rate is adjusted accordingly to the observed performance. This adjustment strategy helped us to achieve improved result and push the boundary of the state-of-the-art performance in graph neural network training. Additionally, this study also explored a real-time visualization using the above-defined approach that provided detailed understanding of graph neural network models and behavior during the training procedure. So, the data set in our study, we aim to explore effectiveness of graph neural network by training them on three different set of benchmark data sets: core dataset, site-set dataset, and PubMed dataset. Some of the advantages behind using these datasets are consists of actual scientific publication, making them highly representative of a real-world scenario. Sorry, it's automatic completion. So the second point to make these datasets unique with the different number of publication classes and features. They provide a diverse set of challenges in a citation relationship. And these datasets have been widely used as benchmark dataset in the field of graph-based machine learning. These points makes us to select in our studies select these datasets. So let's start automatic selection of loss and optimization function. Why we need automatic selection of loss and optimization function? As we discussed earlier, graph neural network require a selection of appropriate loss and optimization function for optimal performance. And automating the selection procedure might eliminate the need for this trial and error approach, saving a valuable time in the model development, and the researcher and developer can spend those time to explore in a different architectures, let's say different classes of graph neural network, graph convolutional neural network, graph attention neural network, and so on. So the right choice can result in improve the model performance of these loss and optimization function, while inappropriate selection may lead to suboptimal or even ineffective training. Right. So in order to automatically select the best loss and optimization function for graph neural network training, performance metrics play a vital role. As we discussed, that the performance metrics play an important role in the training of graph neural network for the selecting of best loss and optimization function. So the performance metrics allows the model to adopt a specific characteristic of the data set, leading to improve the results and better generalization. So in our implementation, we use a dictionary approach that contains different set of the loss functions with their corresponding performance matrices, and the same way the list of optimizer with their corresponding learning rates. For example, the NL loss might be associated with accuracy, and MSE loss might be associated with mean squared error rate, and so on. So that's the first approach, like to use the best loss and optimization function. But that might be a time consuming, right? So let's say that the model has to be used one loss function and then train the whole data set and then come back to the second loss function and then move again with the whole data set. So it's more time consuming as compared to the manual traditional process. So for considering this point, we use a concept of mini batch training, in which we train the model, let's say 25% of the data set initially with the different set of models, and we find at that time that the set of the functions is more appropriate than the B, C, and D, and so on. And the second step was early stopping. Early stopping means that, for example, you set the one threshold level. Let's say that the inaccuracy sense that the 60% of accuracy, that if the following the selected loss and optimization function which is currently in process will not produce more than a 70% accuracy of the model, then stop its process even in a 25% of the data set process and move with the next model. So it also save a lot of time. Implementing early stopping based on validation metrics help us to avoid overfitting and save completion time. So these are the some results. As you can see that in our study, we use a graph convolutional neural network and graph attention network with the number of 2 layers. So as you can see that in Cora GCN, and the best matrix we achieved 0.11 value with the 100 epoch, and the optimizer, the algorithm selected itself is Adam and the loss is the NN loss. The same way for the GAT, we achieved the best matrix value, performance matrix value is 0.129 with the 100 epoch, and RMS prop used for the optimizer selected by the algorithm optimizer, and L1 loss function is selected by the loss function by the algorithm. So let's talk about the real-time training visualization. Why real-time, a runtime tool is required? So runtime tools are required in the following sense. For example, allow the user to make view at runtime output. For example, user can see the output at the runtime, how the algorithm is performing in step by step, right? So it also speed up simulation. Let's say that if you are really unhappy with the you set the dictionary of loss and optimization functions and you want to update, so you saw the result that I'm totally unhappy and I have to stop my code and I have to go back again. So that's also speed up simulation process. It also help in designing, parametric tuning, visualization, analyzing the model. You can see the results, you can update the parametric values, you can see and you can analyze the model in a better way, right? We also believe that our proposed runtime tool is a standalone graphical output tool for analyzing the graph neural network. A runtime simulator not only helps the community to analyze and visualize the model, but also give the user, especially the early stage researchers and students, to fully understand the complex graph neural network structure model. That is quite important. So what we are offering in a real-time training visualization tool, interactive and a powerful environmental tool, perform analysis in order to gain accurate parametric value. User can get the accurate set of parametric value, allow user to interact with the model and observe the behavior of the model at the runtime. A substitute for time-consuming experiment for analyzing and designing model. For example, you don't need to wait for once you run the training, you are blind, right? Yeah, you can do it in a different set of you can set the print the values and you can look at, but that's makes you feeling bored, right? But if you have a graphical user interface, that's make you interesting, that how is it working and and it's also help you learning. So that's basically a substitute for time-consuming experiment for analyzing and designing the model. And also in our random simulator, we offer a fast real-time visualization and a user-friendly tool. Of course, it's an initial stage at the moment, the runtime simulator, but later on we will also improve, make it more appropriate and more user-friendly with the based on the users' feedbacks. So that's a demonstration. As you can see that you can visualize the training loss with the validation matrices. You can see the accuracy, you can see the which loss function is choose at the runtime and what optimizer function, and with the loss function which is choose by the algorithm, what was the output and how it is behaving, right? So that's really a small amount of the recording, but later on, if you will see that, you can see that even the loss function is changing, even the accuracy of the model is decreasing. So it helps you to understand how the algorithm is working and how it helps you to increase your productivity, right? So in the last, what we offer a simple yet effective automatic and a runtime tool that is interactive, fast, and easy to use for understanding the mechanism of graph neural network. We have demonstrated the effectiveness of our approach in achieving the state-of-art results. For future work, as we already discussed, that our main goal was spiking neural network architecture where the optimal hyperparametric value will be automatically selected by the model. A runtime analysis and visualization of graph neural network model will be an interesting area for the future direction. We hope and we are confident that it will open a different direction of the research for the new researchers or the student to think in a way that they can also introduce a better simulators for, let's say, the high level simulators which allow allow them to understand, to learn more better neural network in a way as compared to the like a coding base, because you really need high levels of coding experience to understand how the networks, how the things are working in a step by step, right? So but in a high level implementation, high level simulators will offer you a better understanding in a short period of time. So thank you so much for your attention, and if you have any question, you can contact us with a different platform. You can see the demonstration in YouTube, and the code availability is on our GitHub. You can find out also our contact information on our GitHub profile, and you can reach us with us if you want to contribute with us or if you have any question. Thank you so much for your time.